Hello, I'm Manal, a civil engineering engineer specializing in concrete formulation and bio-based and geo-sourced materials. My work involves developing responsible concrete formulations, mainly by replacing traditional aggregates with alternatives such as bottom ash, which results from the combustion of household waste, with anthracites, which come from the accelerated fossilization of non-recyclable waste, with foundry sand, or with recycled aggregates. In this room, we carry out mechanical tests such as compression resistance and bending on the specimens that we prepare in the mixing room. After 24 hours from making these specimens, we demold them and can either store them in the curing room or test them if the test is scheduled for 24 hours. After demolding and before performing the test, we make sure that the surfaces are smooth. Why? This is to ensure an even load on both surfaces during the test. The bottom surface tends to be smooth because of the mold, but the surface exposed to air often has irregularities. In this case, we will check the condition of the specimen. If it is strong enough, we can proceed directly to grinding to obtain a smooth surface. But if the specimen is not as solid and shows signs of crumbling, we have to perform sulfur capping. And again, this is to have two smooth surfaces, ensuring an even load on both sides. Recently, I started working with foundry sands as a substitute for traditional sand, I would say. I had to replace traditional sand with foundry sands, which absorb a lot of water, and I was able to overcome this rheology limitation. By substituting up to 20% of the sand, I managed to achieve compressive strengths equal to or even higher than regular concrete. Mechanical tests such as compressive strength or bending allow us to verify that the formulation meets the specifications. Several factors influence mechanical strength, whether it's the cement, its type, the quantity, the aggregates, or the amount of water. And here I would like to point out that the more water you add to the mix, the lower the mechanical strength becomes. So, you should never add extra water to the concrete mix just to improve its workability, because this will harm the mechanical strength later on, and you won't be able to meet the specifications. This press is used for freeze-thaw test specimens and for low-strength mixes, but also for mortars and grouts. Whereas this press is used for specimens with high mechanical strength. For cubic specimens, there is no need for grinding since only one surface is exposed to air and all the others are smooth, so the load will be evenly distributed on both faces during compression. And we start the After the specimen breaks, we check the fracture to see whether it is proper or not, in order to confirm that the strength we obtained is indeed correct and that there was no defect in the making of the specimen. Then we can refer to this diagram to determine whether our specimen is acceptable or not. What you need to remember about the compression room is that it allows us to validate the proper formulation of our concrete and ensure compliance with the specifications.